Hey everybody, Mr. Taylor back with Rockin' Math and two-step equations. Before we get started, I want you to take a look at the format here. We are not going to do the diagrams. The only thing we're going to do is use the algebraic symbols. Literally, we're just going to write the equation, do the steps, and check the solution to make sure it is correct. Okay, let's get going, if you don't mind. So it's telling us the given problem is 2x plus 3 is equal to 7. And what we see happening, if we look on the left hand side with the variable, which has a coefficient of 2, we're looking at plus 3 being added. So remember, we said that since that's the last thing that's going on with the side with the variable, that will be the first thing that we decide to tackle. And again, we look at plus 3, so the inverse would be to subtract 3. And remember, we have to subtract 3 from both sides, and that's going to give us, actually, we'll just bring down our 2x, and that's going to be 2x is equal to, so you have a positive 7 and a negative 4. The rules of integers say that you take the absolute value of the largest number, which is 7, and the absolute value of the smallest number, which is 3, and subtract, and we get 4, and we keep the sign of the largest absolute value. So what I'm looking at here is 2x is equal to 4. Okay, we still have an item or an issue actually with x being multiplied. So now we look at, well, what is the inverse operation for multiplication, which is division. So we will put our fraction bar and divide both sides by 2. So 2 goes into 2 one time, 2 goes into that 2 one time, and 1x, actually we could just bring the 1x down, and 2 goes into 2 once, and into 4 twice, and that's going to give us 2. So we're saying actually that x is equal to 2. Now, to make sure that what we've solved is correct, what we want to do is take a look at what can we do to check to make sure. Well, we said that x was 2, so we're going to go up here and we're going to write 2 and times 2, that's replacing x with what we said it was, plus 3 is equal to 7. Now, in order for us to know that our solution or our statement is correct, what we get on the left side must equal what we get on the right side. So what we'll do here is we'll look at 4 plus 3, and we don't know, we'll just say that it equals to 7. Excuse me. We don't really know until we finish the math. So again, 4 plus 3 equals to 7, so that does equal to 7. We have a true statement and an identity. Okay, let's take a look at the next problem. Okay, this problem tells us, and notice that our variable is on the right side. That's fine. I mean, if you want to use reflective property and bring it from one side to the next, if whatever makes you comfortable is what I want you to do. So I see a negative 3 is equal to 2x minus 1. So again, I am looking at the side with the variable. So the variable is being multiplied by 2, but the last thing is being subtracted by 1. So my inverse of subtracting would be to add 1. So I'm going to do that to both sides, bring down my 2x, and that's going to give me 2x. And then again, with my property, if I'm looking at the absolute value of a negative 3, that's going to give me 3, and the absolute value of 1, that's going to give me 1. I'm going to subtract, I'm going to get 2, but I'm going to use the negative sign, so that's going to give me a negative 2. Now all I need to do now is see what's going on with my variable, and of course it's being multiplied by 2, so I want to put my fraction bars and I want to divide both sides by 2, and this is going to give me 1x, and that's going to equal to a negative 1. Remember the rules for addition and multiplication say if you multiply signs that are opposite, you always get a negative. So I'm going to get a negative 1 is equal to x. Now I need to check it to make sure that what I just solved was correct, and I'll go back to my original equation, and here I have a negative 3 is equal to 2 times, and I said x was a negative 1, so I'm going to replace x with a negative 1 minus 2. Now we have these integer rules again that we must get into. A negative 3, we say, is equal to 2 times 1 is a negative 2 minus 2. So same, opposite. So I have a negative 3, and I don't know whether that's correct or not, so I'm going to put a question mark, is equal to a negative 2 plus, what did I, a negative 2. Oh, isn't this wonderful? So now we're looking at what did we do? We must have made a mental error somewhere. So actually, we shouldn't have, according to the problem, if we're going to get a negative 2. So now, I like this. So let's go back and check and see what our original problem, what did we do? Because see, what we're getting is a negative 3 is equal to a negative 4, and we know that is not correct. So let's go back to our problem and see what we did wrong. So we started out with a negative 3 is equal to 2x minus 1, and of course we added 1 to both sides, and we got a negative 2. So when we divided, we got a negative 1. So we said x was a negative 1. Now, okay, look at the error. See, that's the good part about checking. So we actually went in to check and see what was going on, and we found out that we did our equation completely out of character, because it says 2x is equal to 2x minus 1 and not 2x minus 2. But that's okay. All we got to do is literally go back in and change that to 1. Okay, so now we have a negative 2 minus 1, and then again, instead of giving us a negative 4, this side is going to give us a negative 3. So it does create an identity. But we have to make sure that when we checking, and when we're checking, we can determine where our mistakes were or are, and we can go back and retrace our steps to make sure that we did the right thing. Okay. So let's take a look at this problem, and this problem says that 3x plus 5, and that's a negative 5. So we'll make that correction. Plus a negative 5, we're going to put that in parentheses, is equal to a negative 2. So all we have to do at this point is determine what is happening. Now, here's the thing. We see that the operation is addition. But look at what it's adding. Excuse me again. It's actually adding a negative 5. So what's the opposite of a negative 5? And that's a positive 5. So we will add a positive 5 to both sides. Okay. Now, when we do this, we're going to get 0 over here. So we can just simply bring down our 3x. And again, here's what we're looking at. We're looking at the absolute value of a negative 2, which is going to equal to 2, and the absolute value of 5, which is going to equal to 5. Those of you that's sort of wondering what do I mean by absolute value, It's just the distance that a number is from 0 on the number line. So -2 going to the left is 2 units from 0, and 5 going to the right is 5 units. So that's why I was able to translate these to 5 and 2. So here I'm going to take the smallest number, which is 2, and subtract it from the largest number, which is 5, and I'm going to get 3, and I'm going to keep the positive sign because 5, absolute value of 5 is larger than the absolute value of a -2. So I'm going to get 3x is equal to 3. Put my fraction bar, and I'm going to divide both sides by 3. When I do so, I'm going to get 1x is equal to 1, and then of course x just equal to 1. So now I'm going to go back and check to make sure that I did not make any mistakes and that I do get an identity. So here I have 3 times 1, that's what x said, so we're replacing x, plus a -5 is going to equal to a -2. When I multiply, and we don't know that, so we put a question mark there. When I multiply 3 times 1, I'm going to get 3 plus a -5, and we're trying to determine if it equals to a -2. So back again, we are adding two numbers with opposite signs. So we will take again the absolute value of a -5, which is 5, and then the absolute value of 3, which is 3, and we'll subtract, and we will get 2, and because the -5 is the largest absolute value because of the sign, then we will have a negative. So we wind up with a -2 on this side, and it does indeed equal to a -2. So we get an identity, and our answer is actually true. Okay, looks good for us. I think there are 3 more sheets to this exercise, but we're just going to briefly take a look at this one, and hopefully you get some clarity.